Starting. Okay. Right. Bismillahirrahmanirrahim. Right. Welcome back to another lesson on three-dimensional trigonometry here with Ramiez and Ifra from Eddington. Okay. Now, the question that we're looking at the moment is question number 4. From the sheet that was given to the students last week. Okay. Right. Okay. Question number 4, can you see me? No? Okay. This one, this one. Okay. Lovely. Question number 4. It says in the cuboid shown, and the keyword that they're given us here is, okay, cuboid. Okay, we got some measurements. Now, there's a difference between the word cuboid and cube. If we have the word cube, that means every single length is the same. So it'll be 8 by 8 by 8. A cuboid basically means it's a rectangle that's been pushed all the way through. So it's not a square on every face.
A prism.
Okay, so we have 8 by 5. That is our rectangle at the front, and that's been pushed all the way back by a distance of 6 centimeters. That's why it's called a cuboid. So cuboid is based on a rectangle in 3D. Okay, now the first question says we need to work out WY. Okay. Now the key part of this question again is all about being able to visualize the question and being able to interpret it correctly. Now, because the bottom is a rectangle, even though in this diagram that looks like an obtuse angle, it's not an obtuse angle, it's actually a
90 degrees.
It's actually a 90 degrees angle. So I'm just going to shade that in right now as a 90 degrees. So we've got 6 by 8. I'm going to draw that triangle out again. I'm going to pull it out and draw it in two-dimensional. Okay, so that triangle here, this angle that looks like an obtuse angle, because this is the bottom corner of a rectangle, it's a right 90 degrees. Okay, so that's the part where most students get confused. They look at the question and go, oh, it looks obtuse, so they start using, for example, sine rule or cosine rule, when actually we have to use sine, cos and tan, because it's a right angle triangle. That's one of the most important parts, being able to visualize and interpret the diagram properly. So, if you look at this question here, we need to work out the hypotenuse of a right angle triangle. Okay, now if you want to work out the hypotenuse of a right angle triangle, we use the following. We say a squared is equal to b squared plus c squared. That's just one version of the Pythagoras theorem. There's other versions that say a squared plus b squared equals c squared. So that's just one version of the Pythagoras theorem. Here the a represents the hypotenuse, the longest length, and b and c represent the other two lengths in any order. So let's put the values in. So under a squared I'm going to put wy. That's actually what we're trying to find. And under b I'm going to choose 8. And for c I'm going to choose 6. Okay, so at the moment I don't really get confused with the big Y and W's and stuff at the moment. And I'm going to call this little b, call that little c, and that's hypotenuse part is called a. Okay, that's my own labeling which I'm doing in my head for a right angle triangle. That's the labeling to do with this particular diagram. Okay, so if I want to work out wy, I've got wy squared. So I need to get rid of the squared.
Square root.
So we square root it. So we take the squared over.
WY equals 10.
So we have WY is equal to 8 squared plus 6 squared and square rooted. So WY is equal to 10 centimeters. Okay, right. So that's part A done.
Yeah.
So question A. Okay, question 4B says they want to work out dy. Now dy is over here. Now if you look at this triangle now, again, if you look at this diagram over here, we have what looks like here, again, more than 90 degrees because of the three-dimensional drawing that we have. You have to remember, this is a rectangle meeting another rectangle of 90 degrees. So this corner here is also
90 degrees.
90 degrees, even though it looks like an obtuse angle more than 90.
So this question is easy compared to the other ones on the other side.
Okay.
You see like question 6, 7, 8, 9.
Okay, Ramiez, can we just finish this question here? And then we can... Right. Okay, now we have here ZY. Now ZY hasn't been labelled here, but ZY has been labelled over here, which is 6 centimeters. So this bottom part is slanting up, I'm just drawing flat. And then we have ZD. So the height of this is going to be the same as height as WA, which is same as the height YC. Okay. Right. Now we need to work out dy. dy is length over here. Okay. Now, this second part of the question is identical to the first part in the sense we have the two lengths of a right angle triangle. We've got to work out the hypotenuse. So in one sense, what we could do, we could skip right to the last part of the calculation since we're doing the same thing. So we can say dy is equal to the square root of 5 squared at 6 squared. So dy is equal to is equal to
1 second.
7.8, but yeah.
okay, what, so give me the third value first. Root 61. Yeah, leave root 61. Okay. I'm going to leave it in its third form. As I mentioned before in the previous video, this keeps all the information nice and tight, so we haven't lost any of the data values here. So we're not rounding, don't get rounding errors later on if you use this calculation again. Okay, so we worked out WY, DY, now it says WD. Now WD is this length across the back of here, so we have an 8 by 5 triangle this time.
Is this for C?
Okay, this is here, WD. So, again from here to there we have another right angle in here. So between that length and that length is the corner of a right angle triangle, of a corner of the square, which gives you a right angle triangle there. So the height here is the same as the height here, which is 5. And then the width here is the same as the width here, which is 8. Okay, so this is now question 4C. Okay. Right. Now question 4C. Again, WD is going to be the hypotenuse. So if you look at the original method over here, so the hypotenuse, to work out the hypotenuse, we have to do the square root of the other two sides squared and add it together.
The answer is square root 89. I mean,
Root
89.
Okay. So So we now worked out all three lengths. So we worked out this length here, and this length, and this length. So you now got all three lengths now of this red triangle inside the cuboid. Okay, now I'm going to write, most likely for the next question I'm going to have to rub off the whole board. We need to get these values and put them to one side for the moment. Okay, so I'm now going to okay, right now, so let's write over here a little quick summary. So Wy is equal to 10 centimeters. We said Dy
equals to root 61.
equals root 61 centimeters.
And
we have
WD is root 89 centimeters.
WD is root
69, not 89 centimeters. Now
Okay.
to do that equilateral triangle thing.
right,
And
okay.
to do a 2BC and cos.
Alright, let's rub off this board. Okay.
So sometimes you can have a spray that does it like rub better.
Yeah, that's right. Right here. That's if he starts leaving stains. Right?
Yeah, that's fine.
Alhamdulillah, it's not too bad today.
Mm.
Okay, right. Okay, focus on this over here. Okay, the next question is asking us to work at the angle WDY. And the angle WDY,
You have to look at W.
so no, D.
Oh yeah, that's the
Yeah,
one.
so the middle one.
Yeah, that's the one.
Okay, so WDY is that angle over there. Now, if you look at this triangle here, that's going to give us a non-right angle triangle. Because we've got all the diagonals, there's no right angles in that triangle at all. So I'm going to just redraw that triangle over here. Okay, there's my D, there's my W, there's my Y. Okay, and this is the angle that we need to work out.
What question is this?
Okay, this is the last part of the question. This is the last part. So WY, what I'm going to do now, the measurements from the first part of the video, the first part of the question, we're going to write them on there now. So WY was 10 centimeters. Okay, DY was root 61.
WD was root 89.
Okay, now you will see the power of not being mad with continuously giving rounded off values. Because I'm going to use those values again in another calculation, by me not rounding them off and using the original pure value, we will get a much more accurate answer in the next part of the question, because the answers from the first part are now going into the second part and then be reused. Okay, so we have to work out the angle there. Now, if we have three sides of a triangle,
Is
a non-right angle triangle,
three ticks and a cross, so it's
it is three ticks on across, but what we're going to be using
A
sine.
squared equals B squared.
Hang on a second. Are we going to use sine rule or cosine rule? First of all,
Cosine rule.
cosine rule. If you're trying to work out an angle here, we must work out, we've got all three lengths, we've got none of the angles, we must use cosine rule. So let's have a look what cosine rule is. Okay. Right, let's have a look. So let's have a look. What do we know from this rule here? Now, as I said before, I normally relabel the diagram so it matches the formula here. So there's nothing stopping us from doing that now as well.
So A is D.
Hang on a second. So let's just redraw this triangle over here. Smaller. So the angle that we're interested in is going to be the A. So I'm going to relabel my D as A. Now the opposite to the capital A is going to be the little a, which makes 10 equal to A. So all we're doing here, we're just relabeling our original diagram with D's and W's and Y's in it, so it matches our formula with A's, B's and C's in it. Now the cos A is the angle that we're trying to work out, and the little a is the side opposite it. So we've done the first bit so far. Now, B and C, it doesn't matter which one you call B, which one you call C. So I'm going to call this one, I'm going to call W B, which makes this side little b, which is equal to root 61. I'm going to call the remaining side C, which gives us a little c over here. The little c is root 89. Root 89. Okay, right, I'm just going to rub that off a bit and put a bit to the side. Okay. Right, so what I've done, I've got the trigram with the original labeling and relabel it so I feel comfortable when I'm using the formula. A corresponds there, capital A, so this is the two pairs of information. We need to work out the big A. We've got little a, that's little b, so that makes that big B. We call that little c, so that's the big C. So everything now corresponds to the formula. Now let's just double check. So we know all the lengths, but we don't know the angle. So if you look over here, Ifra, right, we know everything apart from the big A, so we can rearrange the equation, make A the subject. So let's make A the subject. What do we do first? We need to move the plus B squared and plus C squared over. So we have now, okay, so we can have now A squared minus B squared minus C squared. So move the plus B squared becomes minus B squared, plus C squared becomes minus C squared. Now, remember what we said last time, Mr. Ramiez?
Yes.
We are multiplying by minus 2bc. The opposite of multiplying by minus 2bc is to divide by minus 2bc. The minus does not get changed, just the multiplying gets changed.
Divide by minus 2bc.
Correct.
You do a bracket and then because you have to bring the, because we ain't got cos, so you
Hang on.
cos minus 1.
And we got then this all time by cos A. So we now need to move the cos over. Opposite of cos is
Cos minus 1.
and that gives you A. So first of all, let's quickly recap what we've done there. First of all, we moved the B squared over, became minus B squared. Then the plus C squared went over, became minus C squared. Then the times by minus 2bc went over, became divide by minus 2bc. And then the cos of A, the function is cos. We reverse the cos. The opposite of cos is inverse cos, that'll give you A. So you need to first of all rearrange the equation. Now in the state we can put in the position where we can put the values in. So let's put the values in, folks. Right, A is going to be, so we got 10 squared minus B squared minus C squared. And we're going to divide that by minus 2 times by B
times root 61
times by root
89.
And then close the brackets and we do cos to the minus 1.
70.1.
And the answer to all that is
70.1.
No, it's 70.2. Round it to
okay, right, let me have a look at the original value, please, folks. So we got 70.165. Now let's write that down first of all. Let's write that down. So we got 70.1659 something. The calculate answer. Now, because we're measuring an angle, okay, we don't need to give it to 2 decimal places, but 1 dp will do fine. So if 1 dp, this number is more than 5 or more, add 1. So the angle D,
70.2 dp.
okay, oh sorry, the angle WDY is equal to 70.2. So that's the end of that question, folks. In the next video, we'll be looking at another question. Okay, thank you for joining us.